Yes, good morning, guys. Today we're going to be covering how to find the area of trapezoids, guides, and rhombi. All right, so it's a very straightforward lesson. Again, it's very short. Just copy down what the objectives. Make sure you understand what you are trying to accomplish, and let us get ready to begin. All right, the formula for the area of a trapezoid is given by you take base 1 plus base 2. You could divide that by 2 or multiply that times the height and divide it by 2, okay? That's one way. Another way that they look at it is 1/2 base 1 plus base 2 times the height. And either one is good, okay? And the reason for that is because when you have a trapezoid, notice I have a trapezoid right here. If I double it, right, here is base 1, here is base 2. But if I take this and turn it around and put it together, notice it forms a parallelogram. So here is your base 1, here is your base 2 times the height. And then you cut it in half because you only want one trapezoid. You see, if you had 2, that would make the whole parallelogram. All right, so let's take a look at this one right here. Let me make sure I put this for you so you could identify the parts. Okay, so here is your base 1, here is your base 2. So you add the two bases, multiply times the height. The height is perpendicular to the bases. Remember that. It's always perpendicular to the bases. And what you want to do is take that's your height. And then you divide that by 2. Okay? Okay, let us look at this example. Here is the state of Nevada. Well, it looks more or less like a trapezoid, right? We have the height. The height is always perpendicular to the bases. Here are the two bases. So all I have to do is find the area. It would be to add the two bases, so 205 plus 511. Take that, multiply times the height, and then divide that by 2. Remember, it's going to be in square miles, so don't forget that even though I didn't put the miles here, the area is always given in square units. Okay, so 205 plus 511. So let's put that in the calculator. That is a total of 716. So we have 716 times 309, and that divided by 2. That would be the area. Okay, so take this times 309 and divide that by 2. That gives me that is a total of 110,000 miles, 110,622 square miles. And that would be the total area. Okay, let's see. Here are two problems that you could try. Once you try them, let's see how you do, and then make sure you pause the video. Once you do it, then press play and take a look and see how you did. Okay, let's take this one for example. We have the base 1 and we have base 2. So we take that information. Base 1 equals 17 meters. Base 2 equals 8 meters. Then we have the height. We are missing that height. See that? We are missing that height right there. But they're giving us this angle, which is 42 degrees. That happens to be the opposite. And this happens to be the hypotenuse. So that's the sine ratio. So the sine ratio of 42 degrees is equal the opposite, which is x over the hypotenuse. Take that 11, bring it forward, So 11 sine at 42 degrees will give me what I'm looking for, which is that height, right? So actually the height equals 11 sine of 42 degrees. So now I have everything I need. So the area is base 1 plus base 2 times the height divided by 2. If you enter all this in the calculator, it will give you a more accurate area, okay? If you find this and approximate this and then enter it to that, multiply times that divided by 2, then it's going to give you something that is close. So that's approximately. Let's say that is approximate. So let's put it in there. So we have 17 plus 8. And that multiplied times 11 sine of 42 and we have all that divided by 2, and it gives us that it's about 92, so it's about 92 and this is in meters, so square meters approximate. Okay, that's the area of this trapezoid. Okay, let's take a look at this one. Find the height of the trapezoid. Well, if I'm going to find the height of the trapezoid, well, I have to put the area is 51.1 square centimeters, which is equal the two bases, 11.1 plus 3.5 times the height, all of that divided by 2. So what you want to do is double this area, right? You multiply times 2 on both sides, so that's 52.2. I'm sorry, 102.2. 51 and 51, that's 102.2. So 102.2 equals 11.1 plus 3.5, that's 6, 4, 1. That's 14.6 times the height. And then divide by 14.6 on both sides. So 102.2 divided by 14.6 will give me the height. What is that height? Let's look at it. That's 7. So the height is 7 centimeters. There we go. Pretty neat. Okay, next in line we have the kites and the rhombi, or the rhombus, right? The formula for that is diagonal 1 times diagonal 2 divided by 2, or half of the diagonal 1 times diagonal 2. Okay, that's the formula. However, we need to know what's important to know about kites. Well, we know that in the kites, the diagonals are perpendicular to each other. And so it is like that in the rhombus. The rhombus, all the sides are congruent and the diagonals bisect each other. And that is true. Okay, what else? What else? In the kite, we know that this side is congruent to this side. This one is congruent to this one. We know that the long diagonal bisects the short diagonal. Then these angles right here are congruent. Also, this angle is being bisected. Okay, and so is this one, okay? Put 4 over here, 4 over here. All right, so those angles are congruent. This one, these are 4 right triangles, so it is in the rhombus, okay? So those are important things to know. Let's take a look at what we've learned so far. Parallelogram, the area equals base times height. In a triangle, the area equals base times height divided by 2. In a trapezoid, the area equals base 1 plus base 2 times the height divided by 2. In the kite and rhombus is diagonal 1 times diagonal 2 divided by 2. So here are the 4 formulas that you should have so far. Let's take a look at this one. Before you continue, make sure you pause the video and see if you could try these and see if you could find the area, and then press play and see how you did. All right, so this is a rhombus. We know that the diagonals bisect each other, so this one and this one must be congruent. So one of the diagonals is 40 feet. The second diagonal should be 60 feet, right? So now all I have to do is multiply these 2 diagonals and divide it by 2. So 40 times 60, divide that by 2, and that will give me the area, okay? So 4 times 6, that's 200 or 24. And then add those 2 zeros, that's 2,400 divided by 2, which is 1,200. So the area is equal to 1,200 square feet. Then we have the kite. In the kite, they give us that this is 20 inches. So this short is being bisected. So this is also 20 inches right here. So one of the diagonals is going to be 40 inches. The other diagonal, I have part of it, but I don't have the other part, this short part right here. Well, we know this is a right triangle. I could use the trigonometric ratios. This is opposite over adjacent. So basically that's going to be tangent. So 20 tangent of 32 degrees is going to give me that short. Okay, so that plus the 26, right? That is approximately, and I could go to the calculator, 20 tangent of 32. That gives me that is about 12.5. So this right here is 12.5 inches. So now that I have that, I could add it to 26. So plus 26, that's 38.5 inches total for diagonal 2. So now I have my 2 diagonals. I just need to multiply them and then divide it by 2. So 40 times 38.5, divide that by 2, and that's going to give me my area. So let's do that. So that's 770, and that is in square inches. All right, so how you do? Let's see. Okay, so here's another example. Here's a rhombus, so we know that this is 10 inches as well. This is a right triangle, and what I'm looking for to have is this third side. So this is a leg, so I'm going to say, well, the leg is equal the square root of 10 squared, the hypotenuse square, minus 8 squared. Okay, so that is 100 minus 64. That means that's 36. And the square root of 36 happens to be 6. So this right here measures 6 inches. Okay, so now I have everything I need. 6 and 6, that's diagonal 1, that's 12 inches. Diagonal 2, that's 16 inches. So multiply them and divide them by 2, right? 12 times 16, divide that by 2. That's going to give me the area of that rhombus. So I'm going to go to the calculator. 12 times 16, divide that by 2. That gives me that is 96 square inches. And then we have another one right here. This one is a kite. Well, I have 18 centimeters for this one. This is 30 degrees. I'm looking for this short part right over here. Let's see, I'm looking for this. That happens to be the opposite over the hypotenuse. The hypotenuse is the last one, so let's go on the bottom. So that would be 10 sine of 30 degrees. Actually, if you notice that the 30, 60, 90, that's a special right triangle. I don't need to use this. I could say, well, the short will be what? Will be half of the hypotenuse, so that's 5 centimeters. And then the long leg is that 5 times the square root of 3 centimeters. Therefore, one of the diagonals is 18 plus 5, that's 23 centimeters. The other diagonals is 5.3 times 2, right? Because it's 2 right here. So that would be 10 square root of 3 centimeters. Now all I have to do is multiply the two diagonals. So 23 times 10 square root of 3, all of that divided by 2. So that's 230 square root of 3 divided by 2. And 230 divided by 2 is 115 square root of 3 square centimeters. And this is actual measure according to those numbers, right? That's the area. And there you have it. So all is left is for you to do the practice exercises, and remember to work hard. And if you have any questions, just come on to me and I'll answer any questions you may have. Well, have a great day and see you in class.